So hello students, let us discuss further. We're discussing about the magnetic effect of current. In this, we are discussing the topic magnetism. Now we are going to discuss that what happen when you pass the current through a current carrying circular loop. Current carrying circular loop. For example, this is a circular loop, and the current in this loop is I. Now I want to find the magnetic moment of this circle coil. If you have a dipole, you know that yesterday, last time we discussed that if you have north pole, south pole, then its magnetic field is from north to south, but dipole moment M, that was M into 2L. 2L is this length. But this is not the case like this. This is a circle coil. Its magnetic moment, according to scientists, is given by I into A. Its magnetic moment is given by I into A. What is I? I is the current and A is the area of this circular loop. If n be the number of turns, then this equation may be written as MINA. That is equal to mina. Now question comes for how we can find the north and south pole of a circular magnet. A very easy method. To find the north and south pole, always remember that if the current flowing is clockwise, then that pole behave as a south pole. If the current is flowing anti-clockwise, then that pole will be the north pole. So this is the method to find this one. It's clear? If it is clockwise, then south pole, and if it is anti-clockwise, then it is north pole. So it becomes a magnet. If magnet, then its magnetic moment is given by I into A. What is A? A is the area. If I suppose its radius is R, then I can write the area may be equal to pi r square. So that will depend. The most important question in class 12 physics is find the magnetic moment of an atom due to orbital motion of an electron. देखो बच्चे, एटम में क्या चीज़ है? एटम में भी तो यही है कि एटम के सेंटर पे न्यूक्लियस है, और यहाँ पे कौन है? एक इलेक्ट्रॉन है. जब इलेक्ट्रॉन रिवॉल्व करता है, इट मीन्स ऑर्बिटल मोशन की बात करो, स्पिन भी है. ऑर्बिटल मोशन करके इफ इलेक्ट्रॉन इज रिवॉल्विंग, देयर इज ए फ्लो ऑफ करंट. If there is a flow of current, then there will be magnet. If there is a magnet, its magnetic moment or magnetic dipole moment is given by current into area. Current into area. Now let us suppose its radius is r, orbit radius. So area may be written as pi r square. The problem is to find the value of I. कर देते हैं solve अभी. So I is equal to what? I is equal to charge divided by time. Now time may be written as 2 pi r upon v. Why? Because you know that velocity is displacement divided by time. So v is equal to 2 pi r by t, t equal to 2 pi by v. So if I put, therefore magnetic moment is equal to what? It will be equal to, yes, इट विल बी इक्वल टू, लो बच्चे क्या होगा? करंट, करंट की वैल्यू पुट करते हैं ई वी 2 पाई आर, एरिया की वैल्यू पुट करते हैं पाई आर स्क्वायर. सो पाई पाई कैंसिल आउट, आर आर कैंसिल आउट, इट इज़ 1/2 ई वी आर. So sometimes CBSE asks the question that prove that its magnetic moment is given by this. But we can further modify it. I'll just show you how we can modify it. So magnetic moment is given by, once again, 1 by 2 EVR. Now equation number, if I write first, you know that according to Bohr postulate, Bohr says that when electron revolve in its orbit, that its angular momentum is quantized, that is L is equal to nh by 2 pi. What is L? L is r cross p is equal to nh by 2 pi. What is p? P is mass into velocity, nh by 2 pi. From this, what will be v into r? It will be nh by 2 pi into m. Put second in 1. If you put second in 1, you get E as it is VR. VR is nh upon 2 pi m. So it will be n outside EH upon 4 pi m. Magnetic moment equal to NE. What is E? Electron charge constant. 1.6 10 is to minus H. What is H? H is also constant. What is the value of H? H is equal to 6.6 10 is to minus 34. What is 4? Again it is constant. What is the value of pi? Value of pi. Pi is also a constant, having value 3.14. If all these are constants, what's about mass? 9.1 10 is to minus 31. So this all values are constant, and this constant is called Bohr magneton. This constant, if I solve, after solving with the help of calculator, I am writing with mu b, where mu b value is 9.27 times 24 ampere into meter square. It is a constant, and this constant, I told you, it is called BOHOR, Bohr magneton. It means each atom behave as a dipole. Each atom behave as a dipole. Show कर दिया हमने. And dipole moment of each atom is given by n into mu b. If you put n equal to 1, it means first order. If you put here, you get m is equal to mu b. This is the definition of Bohr magneton. That Bohr magneton is equal to the magnetic moment of an electron due to its orbital motion in its first orbit. Clear है बच्चे? It's most important, ये याद रखना. थोड़ा सा आगे चलते तो फिर क्वेश्चन आया था कि अर्थ की मैग्नेटिज्म के ऊपर. Earth magnetism. Earth is also behave as a magnet. There are number of parameters, there are number of experiments which shows that Earth behave as a magnet. First question that comes, what are the different experimental evidences which supports that Earth behave as a magnet? So experimental evidences, if I go for experimental evidences, so let us discuss this one in next topic. Thank you.